Okay, guys, you ready for this? This is parameters. It's chapter 18 in the Weber book. I believe this is a very, very important chapter, very important topic in programming languages. We're going to try to move through this thing and pound it. And this is just kind of the introductory slide that kind of refers to and is referenced in the book. And this slide introduces a handful of key terms. Formal parameters and actual parameters are really the biggest ones, right? Formal parameters being the way in which the parameters are defined as part of the function itself or the method or whatever the thing is that's getting called. Those are formal parameters. The actual parameters are the values that are given when the call is made. Okay. You got to get your head around these terms just a little bit, because to me, formal and actual aren't, they're not a big enough separation conceptually. But I think it makes a little sense if you just think of formal as being like definitional and actual being what we're going to really hand in. But really, the question is the fundamental question of parameter passing is just, well, I got stuff, I got to hand it in. But it turns out that check it out, there are 7 different implementation techniques, ways of doing parameter passing, okay? And we're going to walk through each of these fairly quickly. There are a handful that you see more commonly than others, but there's significance and impact in all of them. And in terms of the outline, by the way, we'll just try to move through this. I'll hit all of these at least a little bit and try to focus on the ones that seem the most important. And then what I'm going to do right now is just kind of dive into the parameter correspondence. Then we'll kind of walk through the others and try to keep these into some kind of bite-sized chunks for the parameter. For this podcast. So the first concept is this notion of parameter correspondence, and what this is referring to is the way in which you match up the parameters, the actual parameters and the formal parameters, right? I mean, if you guys, I'm sure, just think of this as, well, there's a list of formal parameters, and then there's a set of actual parameters that are going to be handed in, and well, the obvious, straightforward approach is to assume that these are going to go, in order, and that makes perfect sense, and this is the common case, right? But it turns out that there are other ways of doing it, and there are various reasons to kind of keep that in mind. And you may encounter that if when you get to other languages. And the bottom line again is that positional parameters are the obvious one, right? I have multiple integers internally that are going to be received. I send multiple integers and they line up one by one, right? The nth down here, the nth formal parameter is matched with the nth actual parameter. Makes sense. But another approach that you can take is what we call keyword parameters. In a keyword parameter, you basically disclose, if you will. You sort of pull the name out from inside and drag it out, okay? So in this case, in Ada, and you'll notice, by the way, that this is not really great from an information hiding perspective. You really don't want to have to say, I'm going to call, whatever your favorite pizza joint is, and I'm going to be, I'll call the server, and the server's name is Bob. You'd rather just say, I don't care what the server's name is, the guy taking my order, I'm just going to call. This is not even a great example. If I say, I want 5 pizzas, the guy's going to receive it. I shouldn't have to use their terminology. Does that make sense? And really, one of the things that information hiding does is it takes away from us the need to understand and to use and to be, exposed to the stuff inside. You're supposed to not have to care about that. Well, so what this does is it takes, in this case, the actual parameter is x and the actual parameter is y, meaning that's the value being passed in. And then the formal parameter inside is dividend and divisor. So it basically says I'm going to call divide. Divide has a formal parameter called dividend, and I'm going to say that that's going to be my x. From a scoping perspective, I have to have access to this x. And then the internal to divide, there is a divisor, and then I'm going to say that's going to be y. And in this case, the parameter order just doesn't matter. I've got local variables called x and y. They could be declared anywhere. And I just, call divide. I pass these in. It doesn't matter what order I'm in. That seems kind of obvious. Then what I can do is I can mix those up. And it turns out that a language that you've, been exposed to, Python, and others you have not, like Ada and Fortran and Dylan, allow you to do both, okay? So it turns out that you can do, the first parameters in a list, it can be positional, the remainder can be keyword. And what I'm sort of, just kind of be aware of that, I guess. And what I'm more interested, actually, in a sense, because it shows up in C and C++, is optional parameters, which is a bit of a weird idea and a little hard, maybe initially, to get your head around. Like, wait, I may or may not pass, values. Does that make any sense, right? But what happens is that you basically have interior, and sort of internally, the function or the method declaration includes default values, and it's like, I could take up to 10 things, and I've got default values if you don't give those to me, but if you do, I'll overwrite my internal default values with what you give me, right? And so, in essence, what it's kind of almost doing is like creating a sort of an overloaded function definition, really, at the end of the day. So here's kind of an example from C++, and here is a function or a method f that we're declaring, and as you can see, I've got an integer, an integer, and an integer, right? These three values coming in are integers. Internally, I'm calling them A, B, and C, and I'm giving them default values, and then here comes the body of that function. All right, the function's called f. And so, in essence, what we have done is created, it's almost like we just created, this overloaded collection with these four different definitions. And so one of them would be, here's a function, and that function f is defined as f of, with 1, 2, and 3. In other words, if I say f, do you see the overloading? If I say f and there's nothing in there, I have defaults 1, 2, and 3. So nothing in there. Oh, that means you meant to say f 1, 2, 3 because I've got that interior. If you give me one value, I'm going to say that that's a. So I am doing this thing. It is positional. So if you give me just f and then you pass me a, it assumes 2 and 3, but it uses a. Then if you give me a and b, it assumes 3, but it applies a and b. I hope that makes sense. And then again, if you give me, 3 things, then I'm going to I'm going to cause A will be A, B will be B, C will be C, and the defaults sort of don't matter. And what we're talking about here, these 4 lines, they're meant to be kind of representational. Okay, we're not saying that it's literally coded that way. We're saying that when you code it this way, like the top line, it's as if you overloaded f in the following way. And so that's pretty powerful. If I've got a situation, I don't know if I'm trying to come up with a good example, like if I say, let's go back to pizzas, okay? I must be really hungry or something. Let's go back to pizzas, and if I say, yeah, I'd like a pizza, and there's this default pizza. Maybe it's just a place that serves, you go to a great pizza place like Sette Bello in downtown Salt Lake, and they make this incredible margarita pizza. And maybe the default is just the margarita pizza, the basic margarita. And if I say pizza, I mean margarita. If I don't want, a margarita, then I can say a different thing. But if I don't say anything, I get the margarita by default. And then maybe, I don't know, this is just a really bad example. I'm just trying to say, if I like the pizza example just because I'm making a service call, right? When I call the pizza joint, I'm very much making a function call. So the notion that I don't have to say everything because there are some defaults, like for example, if I don't tell you, if I just go to my favorite joint in Provo, which would be Nickel Italia Pizzeria, and I say I want my go-to is the sausage, just a basic sausage pizza. If I go in there and I say I want a sausage pizza, a medium sausage pizza, they know that it's thin crust. They know that it's the basic stuff with the cheese and the sauce and the sausage, and they have a gluten-free crust. But if I don't say it, I get the basic. If I do say gluten-free, then that will replace the regular wheat flour crust. If I say just no cheese, then the default is cheese. I don't have to say it. I just say pizza. I get regular flour crust, thin crust, and cheese. I mean, I get those things for free. I don't get my pizza for free, but you know what I mean. I get those values passed in as a freebie. I don't have to say those things, but I can say other things that'll cause those defaults to change. That's probably a better example. Anyway, then what we've got is a very cool thing, and frankly, I've shared before that I really kind of cut my teeth programming in C. I mean, that's not true. I really, really cut my teeth programming in Pascal. But sort of post-undergrad, it was all assembly in C. And one of the things that I loved about C that I felt like, I never really got with this kind of power anywhere else was the printf. And the F stood for format. And so you could basically there was this printf call, and I could just tack a bunch of stuff in it. I could throw it in if I wanted, I could not. It was almost like, bundling together, a JSON packet, a format or some XML or I'm just dropping a bunch of information in here. And if I don't say it, I get defaults. And if I do say it, I get, what I'm asking for. Loved printf. It was so cool. And so C and C++ and JavaScript and Python allow you, parameter lists of unbounded length. Okay. And anyway, it is also true that at compile time, I can't check these types. Fine. So that's a hole, right? In the static type systems, that is a hole. But anyway, loved printf. Okay, I'm gonna stop here for this podcast. Come back with the various. Here's our screen, our slide. We're gonna come back and start pounding through these and help you understand those.